Yo, yo! Welcome back. Advent of Code, day 5. Let's get crazy. So we've been doing Advent Code. We're doing it for fun, trying to implement whatever solutions that we find most interesting. Not necessarily trying to get to the right answer fastest, or necessarily trying to get the fastest answer. Not necessarily either of those. Just kind of playing around, seeing what fun we can have by doing the puzzles. So we've done days 1, 2, 3, and 4. If I remember correctly, we are an elf. We are going through the North Pole's secret bunker. There are a bunch of problems on the way as we try to get to, where we have to go. Day 1, we had to enter the passcode to get into the bunker. Day 2, we were going through the gift shop, and in the gift shop, some kid had messed up the database. We had to fix help out our pal. Day 3, I think it was that we were trying to go down. The elevator was broken, so we had to fix the escalator, which got us to the printer shop. And in the printer shop, we had to rearrange a bunch of pallets so that we could. We had to optimize print paper pickup for the forklift to free up some time so that the forklift could bust down a wall for us. So I think that we just busted into some other room, and today we are trying to get a little farther, I assume. Day 5, cafeteria. I love how you're all in on the lore. I don't read it at all. Yeah, well, I mean, what fun would it be if we didn't? Okay, so as the forklifts break through the wall, the elves are delighted to discover that there is a cafeteria on the other side of the wall after all. Right, so we're in the cafeteria now. You can hear commotion coming from the kitchen. At this rate, we won't have any time left to put up wreaths in the dining hall. Resolute in your quest. Dude, I haven't read that word for a while. I should read more. I investigate. If only we hadn't switched to the new inventory system right before Christmas, another elf exclaims. You ask what's going on. Elves in the kitchen explain the situation. Because of their complicated new inventory management system, they can't figure out which of the ingredients are fresh and which are spoiled. That's crazy. When you ask how it works, they give you a copy of their database. Okay, the database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and a list of available ingredient IDs. For example, what was it? So it's fresh ingredient ID ranges, this, a blank line, this, and a list of available ingredient IDs. Okay, sure. So we have to basically just match these into these ranges to see if they're fresh or not. Fresh ID ranges are inclusive, so 3, 4, and 5 are all fresh. The ranges can also overlap. An ingredient ID is fresh if it's in any range. Got it. The elves are trying to determine which of the available ingredient IDs are fresh. And then, so we're counting how many, right? Cool. Okay, so the question becomes, what is a good data structure for this, right? We could have a little map that maps every ingredient to whether it's fresh or not. That's not really that exciting. Can we, you could store the ranges individually, and you could iterate over all of them. That doesn't seem necessarily that great. I don't actually know. I don't have a good data structure for this, right? So again, people in YouTube comments are going to say, why don't you just fucking iterate through all the ranges? It's fast enough. That's not the point. The point is to try to find a fun answer that satisfies whatever goals we have. So what do we have? We're going to have some sort of, the real question is how much part is part 2? That too, we don't know yet, right? So theoretically, I guess you have some sort of finite list of numbers. I guess all U32s is a potential thing here, right? It could be huge, right? And so you have, some ranges in here that are good, and everything else is bad, right? So we're probably going to assume that we're tracking good ranges, and it feels kind of like some sort of tree is maybe how you display this. I don't know. It depends on the ratio of, I was gonna say yeah. So I come in and I have an ID, right? 10. And I want to know, is this good? So I need an efficient way of finding the range that I could be in. It seems like binary trees are usually the right answer to this type of thing, right? If you imagine this as the same problem of just is this in a list of known numbers? Right? You have your options of like hash map, right? And like binary something, right? Like red black tree of some form, like B tree, some sort of thing that like is based off like sorting, right? And it feels like having some sort of thing that's based off sorting here would be nice in the same way, right? You could imagine that you have some sort of like, maybe if you just had a tree um where you start at like the, if you stash maybe the start and end of the range, maybe, right? Like, so you have in your tree, this is 10 to 15, and then you just have your tree kind of walk, anything that's smaller than 10 goes on the left, and anything that's bigger than 15 goes on the right, I guess. Then lookup is quite efficient, right? I think that makes sense. See, I don't think that there's any sort of like hash map style like O1 immediate lookup here. I think because you're working in like what could be very large ranges, some sort of like tree structure is the right answer. Binary trees are always easy, and having something where you just go like left go left, right go like bigger than right go right, smaller than left go left, and then everything in the range is implicit, that feels pretty good to me. That feels like it would be an okay solution. So then what we have to do is we have to figure out how to like generate this tree. And we can probably be like relatively stupid at generating the tree, right? I would assume that there's going to be a lot of lookups and not very many ranges. That would be my guess, right? I don't know. Let's look at the puzzle input. So in terms of this thing, we have maybe like, what's that? Like 100 inputs, and then like 1,000, or like 100 ranges, and like 1,000 inputs, right? Would, something like that. So to me, what seems reasonable is you could imagine the way I would think about this problem is like you probably have we have a known, like the database shows us the list of valid IDs. And then, as we're making stuff, we're ripping through lots of meals over time. I think it's okay to imagine this as pre-processing a list of pre-processing the database, and then the lookup wants to be fast. That's how I feel when I read this. Yeah, so I'm okay with that solution. So let's say, try our part 1 answer. Okay, so day 5. Here we have our DB. Oopsies, const DB is a struct. Here we go. And in here we're gonna have our root, probably. And we could try to get clever with like optimizing in terms of like storage of this thing, right? You could store this as like an array of nodes where you kind of stash like, root, left, right, and then like, left, right, right, left, right. You could do it this way, which maybe isn't crazy. We probably also have some sort of like, yeah, we could do it that way. We could. So this is probably just like a bunch of node. Node in here is gonna be like, min and max, probably, right? This is like kind of like the range of this node. And I guess we're gonna have some sort of like lookup. Or like just contains is really all we're trying to do here. And here we go like, so we start at, nodes 0, right? And, we go like, while true, probably we like walk this list. Probably something like this. And then we have to like derive our next index from here, right? So we need to go like walk left from index to a new index. And if our storage is 0, like it's kind of like we have our first layer, then our second layer, then our third layer, then our fourth layer. Each one doubles in size, right? And the you know, if you imagine your tree like this, it kind of looks like this, right? Something like this. Right, so you know, we're getting approximate. But you know, like each guy, he can kind of walk left and right here. And so who our children are depends on who we are. Very deep and philosophical, am I right? But like, so like how can I easily determine my position in this tree from my index? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, right? Okay. So the like we have our like layer is gotta be some sort of like log 2 based thing, right? So we have like 0, 1, 2, 3, 4, 5, 6. Do I want to do all of this indexing stuff? I'm looking at this like this feels like it's gonna be hard. This is more efficient for like cache efficiency. But I don't know if I want to do it. I don't know if I want to do it because I think it's tricky. Right? It's not as simple. 2 times index and 2 times index plus 1. Maybe? I don't think so. 0, 1, 2. Okay, we need to write this down. This is 0, 1, 3, 4, 5, 6, 7. Oh wait, this is just log 2, right? This is 2, this is 4, this is 8. Presumably the next one is 7 plus the next one is going to have 16, right? So 7 plus 16 is 24. Fuck. Is that right? 7 plus 16. 23. 7 plus 16. 23. Yeah. And then even like getting the layer, I'm not really sure if that helps me. Why 16, not 8? Because there's 8 on the... Oh yeah, my bad. You're right. You're right. You're right. I was thinking of the next layer. Yeah. So it's plus 1, plus 2. So you just add 1? Okay, yeah. So my layer index is power of 2. So my inclination to reach for log 2 was right. And so if I'm... Surely I'm looking at the... Is it index plus 1 here? We might have to special case 0, right? Because is log 0... Does log 0 give me 1? Or does it give me something fucked? I don't remember. Log 2, 0. Yeah. So that's invalid. So we have to be careful there. People are just saying double it and plus to go left and right. Is that true? So if I'm trying to go from index 0, or from index 3 here, I'm trying to get to index 7. That's times 2 plus 1, and times 2 plus 2 to go right. Is that true here? So I'm trying to go to index 4. So I'm trying to go 7. So I'm trying to get to 9 and 10. So double it for 8, 9, 10. Okay, then this is 5. Double it for 10. Yeah, I guess you're right, huh? So here we have index 1. Double it to 2 plus 1. Double it plus 2. Oh, that might be right. That might always be right. That's crazy. Why is that? There's got to be some sort of like crazy math for that. That's cool. That's cool. I don't know why that works, but I do believe you. As far as I can tell, that looks right. That's cool. That is cool. I guess you guys said that, like, a bunch of you guys said that. I understand. But he said it in a way that I understood and it was highlighted on Twitch. So, neat. Neat. Okay. So, I guess it's like, if, first we do node here. We're gonna like pull this out. So self nodes at index, right? And if I guess it's like if node contains val, we return true. We're donezo. Otherwise, I guess yeah, if val, I guess we kind of want like an ordered, right? And we go like this, and it's like if it's less, we do walk left. And if it's right, we do walk right. And if we go contains, we return true. I'm learning programming. When I look at people, I think fuck off. Well, I mean, to be fair, first of all, I don't know if we're doing this very well. Second of all, I've been programming for a long time, right? And, everybody starts somewhere. I don't think that you should really worry about it. I think that, like, that's like kind of like. So, I bought rollerblades yesterday because I think it would be funny to be a guy who rollerblades. And I like fucking had to like if I can put on my bike helmet and I go to like a children's school and I'm like trying to like just turn circles on the fucking pavement. And it's like so embarrassing, right? I'm like a 30-year-old man who's like can't like stand on his roller skates. Right? But it's like if I'm like that guy and I'm like watching like videos of like X Games roller skaters, and I'm like, what the fuck? That guy can jump off a ramp. That guy's doing like quadruple flips. It's like stupid to compare, right? Because I started yesterday. Like, bend your knees. Yeah. I rollerbladed a lot when I was like 10, so like I like remember a little bit, but it's just like getting back into like the flow or whatever. But like the point is, like, I don't think it's like reasonable to compare yourself to other people, especially when there's like a large gap in like time spent on an activity. Right? So like I don't know. I think it's just like just because someone else is good at something and you're not doesn't mean that like it matters. Like that's all I'm trying to say. And then we're all like I'm not really trying to imply that like we're necessarily good at this either, right? But okay. So I guess this is while something. IDX is less than or equal to nodes len, probably, right? And now all we need to do is we fucking need to build this thing, right? So db builder. What does this look like? We want to like create, we're gonna like parse this thing. For me, running on a skateboard is much easier than on roller skates. Yeah, I think that for me it's not. I was thinking about like my chances. I was looking at rollerblades, scooters, and skateboards, all for like just like transportation, general transportation, because I wanted something like smaller than a bike. And I think for me, rollerblades are easier than skateboards because I don't think that I'll ever be able to stop well on a skateboard. Where I think that I will on rollerblades. Just because, like, I skied when I was younger, I didn't snowboard. I think I'm just, like, more comfortable that way. Bikes win for transportation by a lot. Yeah, that's fair. I think that's, like, correct. But if you want to, like, quickly get on and off, I'm not so sure anymore. Rollerblades, you have to carry extra shoes. Yeah, true. True. We'll see. We'll see. Because yeah, I want medium distances. You know, something where it's like I could walk there, but it's annoying. Right? Is like bikes. I think are like too cumbersome for that task. But anyways, how are we gonna fucking build this list? I think. So we start with one range. We start with one range. 10 to 20. We get a new range. First, we check if it intersects with any of the ranges that we've currently looked at. It could intersect with many, right? It could intersect with many ranges. So we probably have to do some sort of. There's probably some way to use the heap as we're building it. But I feel like I'm too stupid for that. So I think what I'm going to do instead is I am just going to keep these things in a list and keep it sorted. Sorted by start. And then every time we push something, we merge left and merge right as makes sense. And fuck it. Yeah. I think this is fine. So here we're gonna be like push range. Right. We're gonna look at here, we're gonna be like I guess can we do like a search? Is there like a binary search in here? Sort binary search, nice. So we'll just figure out where this guy belongs. And we have, well, what the fuck? Compare function is a function that returns an order. Yeah. What is the any type here? Context. I see. So we're searching. So we have like context void. This is our list of nodes, I guess. I don't know. And then we have our compare function, which is something like this. What does it take in? T. Doesn't it need to take in 2 items? Am I stupid? Returns the index of an element items returning EQ when given to compare function. Oh, that's not what I want. I probably want lower bound. Lower bound gives me index of the first element that is greater than or equal to context. That's what I want. And then lower bound compare function is still one thing, which is fine. Does it not need to give me like a fucking... Oh, I see. So my context is a node. I see. And then this function is taking in a node and other. And I'm supposed to return if I'm greater than, equal to, or less than. So I'm looking to see if my... What am I looking for here? You can sort only one time by range start and only merge right now. Maybe. Yeah, I guess I was thinking insertion sort is easier because it helps me merge the ranges. But I guess you're like right that I could just inject them all, sort once, and merge once. And that's probably easier. I agree. I agree. I agree. Yeah, I agree. I agree. Okay. So maybe it's just like self nodes append node. Okay. Cool. And I guess it's really just like more like build db from nodes like this. And here we should try to do something. I don't know what yet. So here we like iterate over the nodes. And we probably want to iterate... No, I think we want to iterate kind of like this, where we have like an index. And I think it's like while true, maybe, not sure what our exit condition is yet. Maybe we have like an out I and an in I. Yeah. Because we have to do like merges here. So I think that we can kind of like edit this thing on the fly, and we can kind of say like, what? Like we're looking for overlapping, right? So we sort by probably start. We sort by start. Oh, hold on. Does that even work? So if I sort by start and I say 1 to 10, then I have like 2 to 9, and then I have 9 to 11. Is there like a way that I can kind of make this so that I don't merge, like the two ones that I want to merge aren't going to be adjacent? I don't think so, because any range that I want to merge will have the lowest part in the range, right? So like everything that I want to merge, anything that I don't want to merge will have a starting index greater than 11, and anything that I do want to merge will have a starting index less than that. So as long as they're sorted by start, then I think we're chilling. So if nodes at in I min is less than or equal to nodes out I max, we say nodes at out I max is equal to the maximum of us and them. Right, so we take the bigger of the two. I think that's right. Else out I plus equals 1. Yeah, I think that's right. And then at the end here, we have like nodes from 0 to out I is like out nodes. This is destructive, which is fine. I don't give a shit. And then here, when we build the thing, I think it's literally just, we take like the middle one from this, and we make that the root. So I think it's literally just like, you might be able to do this in place, honestly, with some swaps. But I think that's harder. So I'm just not going to. We'll just do this. db buff or something. I don't know. Nodes is db buff, and then we go like so how do we do this? We start at like middle index. We start at like left, right, or something. I haven't figured this out yet. It's like we have this array. We know this is the root, and then this is like the next two nodes, and then this is the. No, it's not. It's this, then this, and this. Then this is how we are splitting this thing, right? So I'm not sure if you need to use recursion to get here. I kind of feel like you do. Yeah, probably that's the easiest, right? Is that you populate by going I'm actually not sure. I'm not sure what like the easiest iteration strategy here is. Obviously you start in the middle, right? That's obvious. Then I'm just trying to sort out if like what the easiest way is to make sure that you don't have like off by ones that like result in your tree like not going to the right spots, you know what I mean? But I mean, this is just the same problem again with this array and this array, right? Yes. Probably. Um so you get the midpoint of this, and then you group the left and the right again, then midpoint left and right until you have only two in each. And so then you also need a way to easily convert to the output index, right? Probably. You probably also need to make sure that the like I'm not 100% sure if you can have uninitialized nodes in the output. You kind of need to, right? I think that the output buffer needs to have optionals in here because your length of the array is determining like which layers you have available to you. But at the end layer you might not be populated, which is kind of weird. So there's like something there. For now I'm going to do this. But like validity tracked by bit set? Question mark? And then there's probably a way to balance the trees such that this would never come up, probably, which is like the correct answer, probably, but whatever. I was talking about inserting all the ranges of the list and sorting one. Sorry. No, I think that you're right though. I think that you were right that like sorting the list once for merging, then building the tree after. I do agree that that's easier. I like that better. So how do I do this? How do I do this? There's got to be some sort of like recursion thing, right? So it's like insert into tree nodes probably. Like this is like sorted merged nodes already, right? And then this is the output. And then we're looking for probably like the layer, like the index here, right? So we start with 0, so we just do like sorted merge nodes at the midpoint. Probably, right? And we like take this thing from the midpoint and we just shove that into index. Right? Yeah. And then we go left and right. So we go like db walk left given index, and we take everything left of that, right? So we say like db sorted merge nodes from 0 to index is what we're using here. You know what I mean? Like there's something here. And we do like index plus 1 onwards as well. Like this. Right? So we take the middle point, shove the rest in, and then we stop if we get out. That feels kind of right? So yeah, we just need our exit condition, which is like if I guess like left nodes is this. And I guess we have to check the range first, right? I guess this will always be valid. It's like if index is greater than 0, we can do this. And if index is less than something, db buff len -1. We can do this, I guess. Just going off this. Cool. I guess. And then here we call insert into tree out nodes db buff and 0. I guess. That feels like it might do something. And then we should start with mem setting db buff to null. And now I guess we write some tests and figure out if this works. DB building, right? Sure. Okay, so let's build DB of, here is a bunch of stuff. We have our node, our DB buff is gonna be like, we have, surely we don't need more than this many. Okay. So we're looking at like min 5. I guess here we should sort the nodes first. I guess. Kind of forgot that, huh? Sort does want a context here. So this guy returns a bool. This is a less than function. So we're just comparing left edges, I think. I don't fucking know, man. Left is a node. RHS is a node. We turn a bool and we turn left-hand side min is less than right-hand side min. Okay, cool. We're getting somewhere. This is starting to look like some code. So here we're like min 5, max 10. And here we probably shove in the DB buffer. Okay. And then I think that we need to do a few checks down here. So here, now these are optional, we need to do like, or else return false here. Here we need to return false down here. And we don't have ord on here yet. So this guy needs an order function. And I don't know if we actually want to return an order here. Yeah, we kind of want our own order here. Because we have left, right, contains. Boom, boom, boom. So here we're like return, like if val is less than self min, return left. If val is greater than self max, return right, and then return contains. Easy. Easy peasy. Okay. So here we should be able to do stuff like, throw something in, 3 to 9. We should see something like 4 to 11. All of these guys should get merged, but then like something in between where we have like 20 to 30, and something before that where we have like 40 to 50 or something. Okay, so once we build this thing, what we should see is this should get 5 to 10, 3 to 9 should get merged, 4 to 11 should get merged. So we should have 3 sections, which is 3 to 11. So we should be expecting 3 to 11, 20 to 30, and 40 to 50, right? And so we should be getting that like the DB nodes 0 should be the center one. So we should be getting 20 like this. We should be getting 30 for the max. Then when we go up by 1, we should be getting 3 for the min and 11 for the max. And then we should get one more. So we should be getting 40 to 50. Okay. And we should also be seeing that like that the length of this thing is 3. We should only have 3 nodes. Let's see, Zig test day 5. Let's see what happens. He's mad because this is not modifiable. So true. So here we want to do something that's like I guess we take this stuff and we slap it here. And then we do like memcop, we do can we copy this stuff? Memcopy node input into node buff because we need it to be mutable. Okay. All right, he's mad. We are going out of range on day 5, line 9 here. Oopsies. We should be using midpoint everywhere here, not index. Which he's still unhappy about. So if midpoint is less than or equal to, is greater than or equal to index, return. However, that shouldn't happen. Attempting to use null value. Yeah, something's wrong here. Something's wrong here. I don't think that should ever happen, is the thing. So what's happening here? We are going into 0, walk left, walk right. If midpoint... Where is it? The index is bad? Yeah. Index out of bounds. Index 0, length 0. Oh, because... wait, I'm confused. So DB buff is always the same. We're chilling. So this index is always chill to work into this as long as our buffer is large enough. So the problem is more... Well, this is wrong, by the way. I know this is wrong. This is like a line forward, probably. To next power of 2. Probably. But what's going on here? What's going on here? So it's that the midpoint here is trying to index into a list that's size 0. So this is like, if midpoint is greater than 0, this is fine. It's somewhere here we're inserting like an empty list, but like why? Because if midpoint is greater than 0, this is not 0. So if midpoint is less than db buff len -1, then we add 1 here, and it's like maybe this has to be -2. So like len 10, midpoint 9, index 9, but that means that index 9 is the 10th element. So -2, I think, is the play here. I think. Still, I don't see how sorted merge, like how either of these could ever give a 0 length array. I don't understand how it's possible. It is on the right side. Like, what the fuck am I missing? If len is 10, midpoint is 8, then the right side is 9 onwards, which is an empty list. So it actually has to be -3, which is crazy. I'm so fucking lost. What am I fucking missing here? Am I stupid? Oh, here, this has to be greater than 1 as well. So I'm less convinced on the right side. What am I missing? Okay. Std debug print left is this number, which is this length. Right? What am I missing? I feel like I'm fucking stupid. He's going right immediately and being like, that's 0. But how is that possible? Throw a 3 on here? If midpoint... Oh, wrong. Oh my god. I'm an idiot. I'm an idiot. Okay. Okay, so now we're closer. Can we print what we got now? Alright, what did we end up with? A bunch of nulls and only one guy ever getting in there. So we're not walking correctly now. So we have 3 nodes. Okay, let's go back to greater than 0 here. Because that will be at least 1 long. Let's try that. Close. We're missing the final right guy. However, I'm confused about why here. Maybe running it again? Why would that change anything? Also, what's going on here? Well, this is wrong here as well. Maybe? Yeah, why is this fucked? We must be iterating this wrong. So, can we look at the end nodes as well? Okay, so in nodes, 3, 9, 4, 11, 5, 10. So this guy, 3 is the min of 4 is less than or equal to the max. Great, so this should merge. So we should get 311, which we already just don't get. So like, what the fuck? So we are looking at each input. We say if the input min. Oh, I guess we have to initialize out I once, right? I think input starts at 1 here, not 0. Does that change it? No. So what are we missing here? So on the first iteration, we are at in 1, out 0, right? So here we're like checking if in nodes 1 min is less than or equal to nodes 0 max. So this is 4 is less than 9. So that should be true. I guess we also need to adjust the mins here, which we weren't doing. I don't think this is the bug, but it is worth correcting. Oh, wait, hold on. This first node does get adjusted here. So we take the maximum here of 11. Then we get to 5 and 10, and 5 and 10's chill. So it's that the input... it looks like... Oh. We forgot to do this, I think? We have to copy this one back now? Out first. 3. Okay, now we're missing the last one. The whole ranges can overlap, means you have to search every node. I don't know if you're what you're asking there. So over-engineer it? I don't think so. I think that I'm just slow. I think I'm just slow. So where is my last 40 to 50 going? Where is my last 40 to 50 going? How come we've lost that? How come I've lost it? Because, like, eventually... Oh, maybe at the end here? I think it's out I plus 1 at the end here because the first guy's valid. Yeah, here we go. So here the output nodes look correct. Then does this array look correct? We have 20, and then on the left we have 311, on the right we have 40, 50. This tree looks correct. Now we have to limit db buff here from 0. We have to do like an align forwards, probably. Forward, align forward from we want this to like round up to the next power of 2, I guess. So this is like something that's like out nodes len. Is it really like this? I think it's maybe like this. Not sure. So if this is if I have 1 in here, then I get log 2 of 2, which is 1. Then I should this like 1. Okay. What if this is like my out node's length is like 2? So then I get log 2 of 2 is 1, plus 1 is 2, shifted left by 1 is 4. And then I think this is like minus 1 at the end as well. I'm not 100% on that, but it feels about right. Not really sure. Not really sure. But like, fuck it. It's like something along those. Okay, our test passed, which is good. So the array is looking correct, and now we just want to check like, you know, db contains uh db contains I guess we're looking for things in these ranges. So like 35 should be false. We should be getting like 45 is true. We should be getting like 7 is true. We should be getting 0 is false probably. I don't know, fuck it. Contains can be const. So true right now. Less doesn't exist because it's left and right, not less and right. Here he's mad because we are looking at indexes that are out of bounds here when we go too far in one direction. Could be done in a couple of loops, but I guess it's more fun. Yeah, this is more fun because I like this problem more. This is a more fun problem. Probably less than here, not less than equal. Okay, so that seems to work. That seems to work. And so I guess there's a chance that we get this right. I mean, so the problem here is that like our inputs, like the input list is quite small. So if something starts getting like degenerate as we get into like more numbers, then we're gonna find a problem. But I guess what we can do for now is we can just kind of rip it once and then kind of come back to it if we get the answer wrong. We could also compare, I guess, what we don't even have to actually blindly run it. We can do the stupid version of the problem as well and compare that we get the same answer. And that will give us a good clue for if our solution is like reasonable. Right? Because the stupid answer is really easy to fix, right? Okay, so let's do try std fs current working directory open file of day 5 input. Probably start with example. What are we doing? We're doing like we're trying to do something like, I guess we need like some reader buff. Reader is one of these guys, like this, and we're doing like reader interface take until delimiter. We're looking for a \n. We are assuming that this will always succeed, and if row len is equal to 0, then we are done parsing the node list. So then in this segment, we are saying std format, we're probably doing like index of scalar on the row. We're looking for the dash in here. And so we're saying like min, like the min value is a parse int of the left half. So row from 0 to dash pause. We're probably parsing this as a U32. And we're parsing it in base 10, I think. The max is dash pause +1. Onwards, base 10. And we have our node buff here. And let's say we have 1,000 of them. You know, fuck it. Num nodes is 0 off rip. And we say num nodes here is +1. Okay. Node buff at num nodes is equal to min is min and max is max. Just trust yourself and send the final answer instantly. No. I think it's more fun to guarantee that we're correct. I think that's a more fun way to approach the problems. Okay. So then we should be able to build DB of nodes. Node buff from 0 to num nodes. And we have like DB buff as well, probably. Okay. I guess we start here and just kind of see what happens. Maybe we print it. DB nodes. All right. I guess we need our example, huh? We'll crash in the case that that's wrong. And day 5 input example, boom. U32, these need to be tried. Oopsies. All right. Cool. So we have here two ranges, 3 to 5 and 10 to 20. Now, is that correct? Yes. So that's good. That's good. At the very least, we've got that part right. And then here, we should be able to do while true, we get the next row. Boom. Take delimiter exclusive. And then if we get end of stream, break, else return error. And we say the ID is parse int row as a U32 base 10. And then we say if DB contains ID count plus equals 1. Okay. And then can we do std debug print count is this? That's kind of fun. He's mad. Why? I did write try there for some fucking reason. Try here. Okay. So now can we compare? We need to do it the stupid way as well. We got 3, which is the right answer, which is hype. Stupid count. And here, I guess that means that we kind of need like can we just do node buff 2 here for now? And we'll do node buff 2 here as well. And then we will also compare with a second method, right? So we'll say like stupid contains, looks at the nodes. And ID U32. And we'll just say for nodes, node. If node ord ID is equal to contains, I guess it's just return true, return false. All right. So now we can do if stupid contains node buff 2 from 0 to num nodes, I guess. ID. We have stupid count plus equals 1, and at the end we assert that stupid count is equals count. Okay, so that gets us through that, and now we can run it on our actual input. And we can see if we get the right answer. Overflow. Okay, so our U32s are all too small. We just fucking slap U64s everywhere. We are crashing somewhere because our DB buff is not big enough anymore. We also probably shouldn't pre-printing this anymore, so let's just up this by a factor of 10. Good news, everyone! We got through our smart binary tree and through our stupid way, we got the same answer. So that's really good. Really good. So we can be fairly confident that the answer is 848, unless we're parsing the input wrong. Binary tree, baby. Okay. Part 2. That's pretty sick. I'm surprised it worked. The elves start bringing their spoiled inventory to the trash chute at the back of the kitchen. So that they can stop bugging you when they get new inventory, the elves would like to know all of the IDs that fresh ingredient ID ranges considered to be fresh. An ingredient ID is still considered fresh if it is in any range. Wait. Now the second section of the database is irrelevant. The ingredient IDs that these ranges consider to be fresh are this. So in this example, the fresh ingredient ID ranges consider a total of 14 ingredients. So this is literally just we walk the list and sum the ranges, right? So here it's part 2 count. This is for DB nodes. Node. If no, I guess it's like this is an optional. Or else continue. We just say like P2 count plus equals node max minus node min, right? I think. Maybe +1 because it's inclusive. So if we have 30 to 20, that's 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So it's, yeah, +1. Okay, so can we do it on the example? So 14. Boom, boom, boom. Let's go! Over-engineer part 1 so much that solves part 2. Smart. Well, to be fair, we actually over-engineered it even worse than that. In fact, we didn't even solve part 2 with it, like, the right way, right? Like, we did, like, the merging of ranges already. But our database, was, like, not the efficient way to get that out because we have, like, a bunch of null fields in there. Okay, here's what I want to try. Is performance comparison. So I want to refactor this a little bit just to see how much of a difference what we did made, right? So can we say, let's take the mode here, and let's say that this is from, I guess we have like args here. Args. And we have the process name is the first argument. And then the mode is args next, like this. Commit, maybe, nah. Nah. If, so I guess here we have, if mode is equal to, I guess we like parse the mode, huh? Mode string is this, const mode is stood meta string to enum of smart dumb. Or else return, or else unreachable, or else return error invalid mode or something. We just say here, I guess technically it's better I don't really care about the time for database building. That's not really what I'm interested in right now. I guess we should consider it though. In which case, you're right. Maybe we commit. Day 5. Okay. So, let's have both here as well as a mode so that we can confirm that we're still getting the same answer for both. And then can we do, smart main? Like, we should probably try to, like, do them both as much as, like, true to how we would do it if we only were doing one at a time. You know what I mean? So the DOM solution is kind of like this. No. Yes. We don't build the DB though. That's for someone else. We are only doing stupid count. And can we actually return the count here? I think that's better. I want to do it like this. Okay. So this is stupid main, actually. And then can we do smart main? And this guy, I guess, again, we copy from original main here. We can probably factor out some stuff in here, but, like, whatever. Okay, he builds the database here. He doesn't do stupid count anymore. And then return count. Okay, so now in, like, normal main, we look at the mode, and we switch on the mode, and if it's smart, we do smart main. Dumb is stupid main, and then both, we do maybe something like stupid main, smart main, and then assert here that A is equal to B, and then break block with A. There we go. And then here at the end, we print out the thing. Okay. Cool. Okay, so we should be able to build this now. Zig build exe day 5 zig, and then oops. These guys can in fact error out, huh? Okay, and then day 5 stupid. Invalid mode, dumb, my bad. So we have dumb, we have smart, and we have both. And then in smart mode, we should not be fucking printing like that. Okay. So now we have both smart, stupid. Oh, dumb, sorry. And now what I want to do is I kind of want to get the list of elements through like an RNG instead, so that we can kind of like really just crank out more options, like really rail the database with more questions, right? So can we want to make sure that we're doing the same things for both. So can we do like ID iter here? Where we have like like rand is stood random in here. Next is literally just like return self rand can I just do like int? Like literally any int? I think that's reasonable. And I like wrapping the type here though, just to make sure that like even though it's silly, can because it's just a rand, it means that like we're kind of forced to use the same thing in both. You know what I mean? So can we go like 4, 0 to... Oh, here, we can also put the limit in here. Right, so we can go like, there we go. So now this is less stupid that this is like this. Self, if self I is greater than or equal, I guess, 10,000, we'll just hardcode it here. This is return null. We do I plus equals 1, and we return random. Easy. Okay, so now we have while ID iter next. We have ID here. Delete all this stuff. Boom. Then this happens in smart main as well. Cool. Oopsies. Like this. And now we probably want like in it here. Oh, this is annoying because the RNG needs to live somewhere. RNG is equal to RNG like a stood random default PRNG initialized with 0. Then we have this guy. Rand is equal RNG random. And then this guy goes in here, and here, and here, and then we have to reset him here somehow. Which I think we can just do like this. But maybe we have to be a little careful. So maybe we just do it again. Okay. Not quite right, because here this guy needs to be mutable. Smart main here is not getting what he needs to get. Okay, so can we run with both now? Everyone's happy. Count 0 is a little crazy, so maybe we should do a little bit of int range. Probably because like the number, we're just asking for all U32s, which is crazy. So ID iter. Can we get more likely to be in the range? What is our day 5 input in here? It might be. Maybe we're not doing enough. I mean, the collision chance is so low if it's a U64, right? So how... I guess we could do, like... No, also U32s might be not enough. Yeah, we need something that is like likely to get numbers from the range, right? So I guess unfortunately we kind of have to parse the list once. In order for it to like have numbers that we can pull from. You know what I mean? So can we do something that's like, I don't know. I don't know, man. Something like this. Something like this, which means that all of this is now like nodes is parse list with node buff. I don't know. I don't know. What's the difference between part one and part two? Basically nothing. Basically nothing. Part two was like, can you just tell me all of the valid nodes, essentially, which we already had. Which we already had. Okay. So now we can parse the list in main as well. And we can do this. And then can we in here do like if rand like int range at most 0 to 100 is less than like 20, you know, we will pull from the list. So val like index like node index is int range at most from 0 to nodes len. And then we have return something in the range of 0 of nodes at node index min and nodes at node index max. So now we should have hits on the fucking thing, which is a huge win for us. Hopefully. U64, which means this should be U64 like this. 179 is mad because this guy can error. We've got to try somewhere. Probably forgot over here as well in a couple places. All right. Cool. Day 5. Does it still work? No. Fuck. -1 here. There we go, maybe. Okay, they both get the right answer, which is beautiful, and we have a count that's non-zero. So now we can start cranking this number up until it kind of takes a while. Release fast. And then can we do day 5 smart dumb? Okay, we can go higher. Oh, oops. That exit condition has to go at the top. Smart. Still really fast. 2 orders of magnitude higher. Smart. Okay, 1 order of magnitude too high. Smart. Okay, maybe double it, maybe triple it. Smart. Okay, there we go. Okay, and we can performance compare. Poop it, baby. So this is day 5 smart and day 5 dumb. This is what we're trying to compare. How much faster are we? How much faster are we? Just over double. Just over double. It's pretty good. Pretty good. Look at us go, man. Look at us go. Look at us go. How exciting. What a fun little waste of time. Cool. Thanks for watching, guys. I think we'll call it there. We could probably go farther, right? Like our binary heap implementation, or not binary heap. Is this a binary heap? What the fuck did we make? We made a binary tree, I guess. Our binary tree implementation is like not very like smart, right? We could definitely get this to be faster, as well as we get the parse it, like the creation of the list to be faster. But whatever. I'm happy with that for now. Cool. Yeah, if you like what you saw, we're streaming Advent of Code till it ends, probably. We'll see. Maybe we'll get bored. We're also working on a Wayland window manager. That's kind of what we're going to get back to once this Advent of Code thing finishes. We're getting sidetracked a little in the other segment of today's stream was looking at writing a VLC plugin, so we might be doing a little bit more of that in the next week or so. If you want access to the VODs of stuff that isn't Advent of Code related, or, you know, main topic related, I guess is a better word for that. We post the second half of the stream goes on Patreon or on YouTube members or archived in Twitch VODs. If you pay in the appropriate place, you get access to those and you get the knowledge that you were helping the stream continue, because one day I'll run out of money and I'll have to get a job again. And so at that point, I'll probably stop streaming. Anything else? I think that's it. Thanks for watching. Happy Friday. YouTube, peace out, and Twitch, let's find someone to raid.